Good morning, everybody, and thank you for joining us today. My name is Christabel Ortega. I'm here co-presenting with Michael Sherman, ICS Platform Solutions Engineer, and Kelly Winkler, ICS Platform Solutions Analyst. And we're excited to share with you a success story about how Phillips 66 is leveraging the power of open source to drive real-time optimization at the edge. We'll be focusing on their innovations, use of machine learning and edge computing to achieve tangible results in the energy sector. So the agenda will give a brief on Phillips 66, understand the energy sector, use case, the SUSE solution, results, future directions, and Q&A. So before we dive into the details, let's take a quick look at the history of Phillips 66 and their achievements. By implementing real-time optimization at the edge, they've seen quantifiable benefits such as reduced downtime, improved efficiency, cost savings, and even generating new revenue. This has not only delivered tangible results, but it's also simplified the management of their operations.
Hello? Okay, hopefully this is a good volume for you. Thanks for that kickoff, Christabel. And I am so excited to talk to you guys today about Phillips 66's unique journey with machine learning. But before I get into all of the details, I did want to take a few minutes to talk to you about some of the background of the company so that you have, I guess, more context for the why we're doing this project, and also for context for our use case specifically. Providing energy, improving lives is our company slogan. What does that mean? Phillips 66 strives to be the leading integrated downstream energy company, encompassing the midstream, refining, and chemical spaces. Our midstream operations comprise transportation of crude and natural gas liquids, or NGLs, as you'll hear me refer to them throughout this presentation. Our refining and renewable sector is responsible for turning that transported crude into chemicals and also further into the many products that our world needs to function. And I'll get into exactly how much we help with that on the next slide. But before I do that, I did want to highlight some of what our company has to offer, since not everybody knows. Everyone knows that a refiner creates oil and gas. After all, that is what the industry is named after. But oil and gas, while a large part of what we do, isn't the only thing that our company sells. This slide right here summarizes all of the market segments that Phillips 66 touches. The obvious one, the first one listed there, being transportation fuels, as you all know. But some of the ones that you might not be aware of come from our chemicals business, which helps to create personal essentials like sunscreen, cosmetics, and even clothing. Plastic is another big one, which you know touches all of pretty much every retail industry. And one that hits a little closer to home for my team and also for the folks in the room here is the technology industry, where our byproducts can form components that go into building mobile phones, computers, televisions, and even electric vehicles. Okay, so I promised numbers on this slide, so I'll just go ahead and jump right into it. Phillips 66 operates 11 different refineries, 9 of which are located in the United States and 2 others in Europe. And this actually includes one very special refinery which produces fully renewable diesel, if you didn't know that. By operating these refineries, we process up to 1.8 million barrels per day, which, to give you some more context, because you probably don't know how much is in a barrel, it translates roughly to about 27.5 billion, that's billion with a B, gallons of refined product every year, which is quite a large number. Some of that product might find its way into your cars or anything that you own that might have a combustible engine through one of our 8,500 branded stations around the world. like Phillips 66 in Middle America, 76 on the West Coast, Conoco anywhere in between, kind of interspersed. And if we have anybody in here from Europe, our Jet and Co-op brands, which are located there. Our midstream business operates about 70,000 miles of pipeline domestically, which enables us not only to transport the crude, but also operate the full wellhead to market value chain for NGLs. And this picture on the right side of the slide there is a very, very high-level overview of how Phillips 66 operates. I will definitely not be going through every box here because A, it would take me a very long time, and B, there are parts of this that even I don't understand that well. That's not my wheelhouse and certainly not what they pay me for. But I will try my best to give you the 20,000-foot view. Firstly, we acquire the crude on the left branch there, and we also gather and process the NGLs kind of at the same time on the right side there. We provide transportation for us and for any other customers or companies. And finally, we refine crude and fractionate NGLs to produce the chemicals and other products like lubricants, of which we are a leading manufacturer. Now, one thing that you might have noticed that I have not touched on yet is how exactly we acquire the crude to begin with. Phillips, being a downstream oil and gas company, only acquires crude by buying it from other companies, other upstream companies specifically. We don't actually do any of the scouting or the drilling or the researching that goes into getting the oil out of the ground, which brings us to why our company is very, very motivated by the benefits of machine learning and open source technology at the edge. To extract the most value out of the product that we acquire, we have to process it at maximum efficiency. Up until we started implementing machine learning, the plant is run via human operators and their distributed control system software. And they do a pretty good job of keeping the plant running. But we didn't want to stop there, obviously. Like Colonel Malachowski said on Tuesday in her keynote, which hopefully you were able to attend. It was a very motivating speech. She mentioned pushing the envelope, right? And so we wanted to do the same thing here. And from there, I will go ahead and hand it over to my esteemed colleague, Michael, to get into the details of how we use open source technology at the edge to drive process optimization.
Thank you, Kelly, my esteemed colleague, and Christabel. So every company has an obligation to the shareholders and the customers to dig deep and for cost savings and wring out maximum value from the operations. This extends to proper stewardship of resources, which is critical for our industry. We want to provide energy to our customers in the most efficient way possible. And ultimately, we want to convert the maximum amount of raw resources to final product possible. In other words, optimize the input, output, and throughput of the process. Our engineering team worked on a solution that utilizes machine learning to optimize throughput, putting more feedstock to work per drop than ever before, and the results have been nothing short of astounding. So how does this work? So the foundation of every machine learning model is going to be your historical data. So we have tons of data. And like a good recipe, it all starts with quality ingredients. So you need quality data. The model is then built from the knowledge of the process and that data. It is validated and tested and then deployed in our infrastructure. After deployment, it uses the runtime values of process to then drive optimization in real time. So all that sounds really great, but what is behind that? Well, our infrastructure. So our infrastructure platform needs to provide the tooling to support uptime, resilience, reliability, monitoring, observability, alerting, performance, manageability, security, confidentiality, you know, the whole gamut. So a lot of those technologies, of course, are provided to us through cloud-native resources that we, you know, get from SUSE. These technologies provide benefits, all of those benefits. For us, scalability is not a huge priority, so we don't have to scale to demand of like a typical customer-facing application. We have a pretty well-known pathway to operations. Where we do need to scale, though, is with additional processing. As we add more units to our system, we will likely add nodes to that cluster. Let's see, going forward. So what are we solving? We're solving with this solution, we're solving reduced latency, time from the process data to a set point generation. Real-time insights into remote locations. We're not in the cloud, but we need this information in a central location. And also knowledge gaps. So our solutions team supports us with closing those gaps and making us skillful to achieve a viable platform. Okay, so just give a quick overview of our architecture very generally. So we have a machine learning model that comes in. The application and the model are jointly developed by a third party. We bring those assets in through a pipeline, a DevOps pipeline that we scan and push and store in internal registries. After that, then we can decide, based on where that application and model are going to be deployed, which site we're going to send them to. Okay, so we have to schedule that with our business. We can't just deploy at will. So we work with the business to schedule when those applications and models are going to be put into play, and then we work with that group to do that. So once the application is where it needs to be, is tested, and then we hand off to the operations.
All right, so what role did SUSE play with Phillips 66? Along with Chromeware services, they provided the consulting along the way with SUSE. The Rancher platform provides a simplified solution for deploying and managing, specifically around being able to deploy and upgrade Kubernetes clusters. This allows them to easily spin up and manage Kubernetes at the edge, even with limited IT staff on site. They're able to monitor and troubleshoot, which they're able to gain visibility into the health and performance of the edge clusters from a centralized location, simplifying troubleshooting and reducing downtime. This is critical for real-time applications where immediate action is required. We're also able to provide enforced consistent policies, implemented standardized security and access control policies across all edge locations. Along with that, lightweight and resource efficient. Edge environments often have limited resources, CPU, memory, storage. Rancher's lightweight architecture and optimized Kubernetes distribution, RK2, minimizes resource consumptions, making it ideal for running on small edge devices. This allows Phillips 66 to deploy their ML workloads even in resource-constrained locations. And then offline operations and edge autonomy. Rancher support for offline operations allowed edge clusters to continue functioning even when disconnected, ensuring real-time ML applications remained operational. This is critical advantage for remote or geographically isolated operations. If you guys have not seen a refinery, they're very far away. I believe at some point, like it's almost a town in itself. So with that, known, it's very difficult to get connectivity out there and even being able to get resources out there as well. And then the last thing too is compared to proprietary solutions, Rancher offers a cost-effective way to manage Kubernetes at the edge and then scale. Yeah. So, to revisit some of the results that Rancher has been able to provide Phillips: reduced downtime, improved efficiency, cost savings, revenue generating, and simplified management. I know you guys probably want numbers, but those are confidential. And so, where does the future direction go from here?
Yeah, so right now we're operating at 2 different sites, and we hope to expand that to all the rest of our refineries at least, and maybe even potential some other of our midstream sites in the future. And we're actually, just from SUSECon alone, we're really interested in the full Edge suite that we've been talking about. We hope to implement that as well, because right now we're kind of doing the whole version shuffling thing. It can be quite a lot to keep up with. So, yeah.
So, this demonstrates their commitment to innovation, leveraging technology to drive their future success. So with that, I want to say thank you.